video about design pattern. So in this design pattern, basically I am covering on behavioral design pattern. So like I mentioned you in my previous video also, I showed there about chain of responsibility design pattern. So again, I'm coming I came up with another design pattern called interpreter design pattern. So again, this is a behavioral design pattern. So we use this design pattern very often during our if you are a Java developer or mobile developer, you must be using their Java APIs, and without knowing that beneath it, interpreter design pattern works. So so basically, what is interpreter design pattern? If I ask this, so this design pattern is a, first of all, it is a behavioral pattern that you use to represent the grammar of a language. So, I'll tell you about the what you mean by a grammar of a language. So basically, a lot of tool use this pattern when parsing various aspects of grammar. Suppose you have a string, let's say my name is Abhinav Tripathi, and you want to check that whether Abhinav is present in that string or not. So these are the various, aspects of it. And you can think, it is used by Java also, like regex. We usually use all those are, beneath of behind the scene, it uses the interpreter design pattern. So the concept surrounding why you would choose the interpreter pattern, or that, you know or that it, the way it represents the grammar. So this could be, this could be anything. I gave you one example. This could be music notations, mathematical equations, or even another language. Compilers will use interpreter pattern too often. So this goes hand in hand with representing the grammar, but we can then use it to interpret a sentence, right? So this enable us to map out a domain specific language. If you have ever used a SQL or an XML parser, this is the exact thing. That is, this pattern was designed to do a define a language that can be interpreted to do things. You will often use an interpreter use you know when defining an abstract syntax or tree, so something like that. So to to give you an example, the Java util pattern, the pattern class used to represent a compiled regular expressions, right? Which is incredibly powerful way to search throughout the strings. Another representation is, in the Java classes, is an abstract based class that is used to represent local sensitive content such as dates, numbers, strings. So we'll discuss about all those things and what it is with the demo code and all, right? So I'll show you. I'll show you a Java API. Basically class with the demo of it. So this is, you can see, I have created a interpreted Java API demo. Very simple, mm, very simple class with the main method, where basically I have an input string, which is lion and tigers or bear of my own. You can create any type of input string here, so it's up to you. Now, see this pattern. This is what this is. Again, if you go down it, you will see it is a pattern class, right? um, you can find it, this pattern class, inside the Java API. The if you see the explanations of it, there are a lot of things has been written in this, right? So you can go through it, but the moral of the story is this way of implementation uses internally the interpreter pattern. So I'm what I'm doing is like my patterns compile types are like you compile this and you find you can define your matcher. Like here I've just passed the input one, but you can do anything. You can input win lions only, tigers only, or bears only if you want to choose one. And this is a simple while loop, which is basically will loop till it finds uh, the the input that you wanted to see. So if I run this, okay, sorry, I ran a different. So if I run this, so let's go to the terminal. Yeah, you can see found a lion, triggers, tigers, bears. Oh my, because I have passed the entire sentence. You can choose either lion also, tiger also. This is what the uh, interpreter pattern. It's interpret the your string and the and tells you sometimes if you are working on a very complex project, very big project. So sometimes to follow the standard coding practices and all, you need to we tend to avoid the um, writing much of the if else conditions or switch conditions. So in that case you can define things. Or suppose you have some product where you want to do some specific operations and you tend to avoid the if else conditions there. So you can use this design pattern. It is very helpful. You can create your own interpreter, like based on this condition this will happen, or this based on this condition this will happen. So let's look a real time expression, basically a real time implementation. So this is my again a interpreter demo class. For the time being, just ignore this, and this I'll explain you what are those things. So I have a main method here. I am basically searching whether lions tigers are present in the input that I'm providing, and these are the expressions and alternate options. I'll tell you here. What I'm doing is I'm basically building a tree. So basically interpreter pattern is what. So suppose you can think of a tree, right? How there is a root, beneath that there is some element, beneath that there is some element, beneath that there is some element. It keeps continue, right, that way. And if you want to search very specific thing from those trees, you can easily go for this pattern. So what I've done is, what I've done is like I have created an expression. So let's see what is expression. Expression is an interface. You can choose abstract class also. I have chosen the interface, and I'm just I have created a method boolean, which is basically accepting a string argument, and it returns a boolean value, right? And I have created terminal expression, and I have so what what this terminal expression does is like it prints the data, whether it is true or false. As of now, I don't have complex project, so I try to print it on a terminal. So my this class is what it is doing is like taking an input and interpreting it and giving the result. So I have implemented expression here. So once I implement the expression in my terminal class, I have this will override this interpreter, like with the input string. So this I have written from this I have written. What I have done is like I have used a screen tokenizer, and I've passed the input, and in the loop I am basically checking with hash mode tokens, and I am basically getting next token, and I'm testing it whether that is equals or not. If that is equals, return true, else false. What you are looking for is equal, then return true, else return false. This is very simple. You can replace this terminal expression with your live projects, classes, and all. So again, let's jump back here. So I am basically passing lions and tigers and bears. I have created multiple expressions here, right? Now, if you see here, I have created an and expressions and or expressions. So, like coming, if you have remembered just now, I told you like the you can, if you want, if you tend to avoid if else conditions based on some, your complex product scenario, specific project requirement, you can create, right? You can avoid writing complex if else conditions which and writing everywhere, so you can do something like this. So I have created an and expression, and along with that I've created an or expression. So let's see what is and expression and or expression. So this my and expression class, if you see, I have created a two expression which is null, and I have a constructor. I am basically passing that constructor and setting it here, right? Now, since I have implemented the expression, so once you implement expression, then you need to override this interpreter. So that is exactly what I have done. I have overridden that. Now here, if you see, I have returned what? Expression one interpret context. Context is, I mean, basically it's a input type, string input type, right? So whatever I'm interpreting, whatever I want to interpret, I have just passed it here. So interpret one and expression interpret, expression two interprets. So what is my expression one and expression two here? Expression one is lion and tiger, so interpret that lion and tiger within this and expression. So this is what I'm doing, and similarly the same thing I'm doing in the or expression class. So this class is again implementing my expression class, and I've created two expressions here, just created a constructor, setting that constructor. Now here, if you see, I have done kind of similar thing. You can do your own based on your implementation. You can replace this statement. So it is not mandatory. And just for demo, I have kept it simple. So expression one interprets the context, expression two or expression two interprets the context. So here I have created an alternation one and alternation two just to give you demo. Like here in alternation one, I am checking my end expression, and alternation two, I am checking my or expression. So I am passing terminal 2 and terminal 3 here. And alternation 2, I am passing the alternation 1, terminal 1 and alternation 1, and I'm basically returning an end expression of terminal 3 and alternation 2. So there are multiple types of input you can define. I have, just for testing, I have written this, and this is my input string. I want to find whether it is lions and bears are there or not in my expression that I've created. So here basically I need to define the build interpreter tree. So this, if you see, this is a static class, sorry, static method, right, of expression type object. So basically I have built the trees of the interpreter which I want to interpret, right? So these are my these are I want to do. In your case, it might be different. So you can define based on your project requirement. So let's run this. Let's check it how it works. Yeah, so lions and bears are true. Suppose if I comment it and I just open this one, if I just run it, yeah, lions tigers is false, right? Why lions and tigers are false? Because if you go to the end expression here, I am checking and expressions, I am passing. So both of them are true or not. So if I pass only single expression here, so let's pass a single expression and see. Tiger, what it will check. Try to think. Yeah, tiger is false. So that way it works, and this is kind of very simple example. You can go through it. I'll provide the GitHub link, and or if you wish, you can see the code also. It's very simple. So I'll just discuss few pitfalls of it, right? So now that we have created our own interpreter, let's look some of the pitfalls of it. If the grammar becomes very complex, it can be difficult to maintain fast. As you noticed in our rule example that um, we had, you could see very quickly that if I started adding these different answers or combination, it could becomes a little bit interesting to try and debug and walk through. So complexity can be an issue there. So there is at least one class per rule. So every time we create one of our new expressions, we're creating another class. Complex rules will require multiple classes to define them. So that's where the difficulty of the maintenance can come into play. So the use of other patterns might help with you to specific implementation of complex interpreter, and adding a new variant requires us to change every variant of that class. So the interpreter is a little unique compared to some of the other patterns that we have looked at, and because it's fairly simple, specific to the problem that you are trying to solve, to better understand when we should use these or different patterns. So so suppose if I compare with another behavioral design pattern, like similar type of pattern, which is a visitor pattern. So the interpreter and the visitors are very similar in structure, but a different focus on the implementation. The interpreter has access to properties because it contains the object, the functions that are defined as methods. And since we extend extend the implement the base interface, each interpret function is a, is contained within a method. So one drawback is that adding new functionality changes every variant. Recall the demo that I have just given you, that that we have done. So when we build the expression tree and the complexity that we could get by calm compounding those expressions together, the visitor is actually very similar to the interpreter with some slight variations. Instead of the you know having access to the properties we need, we have to implement the observer, to gain the access to those properties similar to the interpreter. Functionality is found in one place, but it is a visitors and not the expression object that we're building. And just like the interpreter, adding a new variant requires changing the every visitor. So the focus is more about whether you are adding more expressions or grammar rules or adding new visitors to interact with it. That is the main focus on choosing one over the other. So with that, I am just ending this session. I wanted to keep it short. Thank you everyone. Please like and subscribe to my channel.